Alright, in this video we're going to be looking at graphing inequalities. We're on page 409, 4 through 8, 17 through 24. Problems 4 through 8, if you have any questions about those, review the video from 14 and 15 of October dealing with verifying solutions. Go to the flip video tab and scroll down quite a ways, and that video will explain that thoroughly. I'm going to look now at problem number 22. They give us the inequality x minus y is less than or equal to negative 11. Well, we're going to graph this inequality. Just like any other graphing, we need 2 points. There are multiple ways I can get my 2 points. One way would be the x and y intercept method, where we substitute 0 for x and y and find the other value. Another way is to solve for y and then substitute values for x, find the corresponding values for y. I'm going to use that method here, not because it's the most efficient in this case, but because we do want to see the graphing using the calculator. So solving for y, I will first eliminate my x term. It's a positive x, so I'll subtract x from both sides. The x subtracts, leaving negative y on the left. Preserve the direction of the inequality. This says negative 11 minus x. We will write the x term first. Well, we have one more step. We have a negative y. So it's like a negative 1. That's my implied coefficient. Dividing both sides by negative 1. Negative 1 divides negative 1 to leave y on the left. We change the direction of the inequality. That only happens when we multiply or divide by a negative. On the right side, when dividing by negative, both of these signs change. It becomes plus x and plus 11. Right. Now we're prepared to graph. One point I can see immediately, 0 pairs with 11. This is my y-intercept. Now I can substitute any value for x and find the corresponding value for y. I'm going to use negative 4. Substituting negative 4 for x, negative 4 plus 11, that's 7. So we have the points 0, 11 and negative 4, 7. Let us graph those. Since I have relatively higher values for y, I'm going to move my x-axis down a little bit. Might aid in my graphing. Alright, 0, 11, that's my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the point, 0, 11. Negative 4, 7, negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. These 2 points are those. Now I need to connect these two. The question is, should it be dashed or solid? Well, when there is an equal to with our inequality, when there's an equal to with the inequality, it produces a solid line. If there is no equal to, if it's simply a greater than or less than, that will be a dashed line. Simply a greater than or less than dashed line. When we have an equal to, solid line. So I'm going to connect these 2 points with a solid line using a straight edge. And there is my line. I note that the line has a positive slope, and I knew that because the coefficient of x in this case is a positive 1. It has a y-intercept of 11. Well, lastly, we must decide which way to shade. Should we shade below or should we shade above? We have multiple ways to deduce this. One way is to simply test a potential solution. The one I'm going to try is 0, 0. 0, 0. So now I'm going to test 0, 0. And this part of this solution will help for the first part of this problem. I'm going to test 0, 0 in my initial statement. My initial statement says x minus y is less than or equal to negative 11. Well, substituting 0 for x and 0 for y, 0 minus 0. Well, 0 minus 0 is, of course, 0. So we have the statement 0 is less than negative 11. Well, this statement, 0 less than negative 11, is false. 0 is bigger than all the negatives. Since this yields a false statement, I know this point 0, 0 is not a solution. Is not a solution. Okay. Since 0, 0 is not a solution, we should not shade 0, 0. That is, it will not be in what we call the half plane that is the solution set. We should shade in the opposite direction. What this shading is indicating is that all points in this shaded region are indeed solutions to this inequality. For instance, this point here, that is negative 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 5, positive 11. Negative 5 minus 11 would be negative 16. Indeed, negative 16 is less than negative 11. This point is a solution. It yields a true statement. Any point in this region, the unshaded region, will yield a false statement, which we saw with 0, 0. Lastly, we can use our graphing calculator to graph this inequality. So, I'm going to graph this inequality, y greater than x plus 11. Go to my grapher, B. I have a previous graph. I'm going to hit Menu, 1 for Actions, 4 for Delete All. Delete everything, yes. Now I want to enter in my new inequality. Tab. It says F2. I'm going to scroll up to F1, deleting the previous function. X plus 11. X plus 11. Now I want to get this new symbol, greater than. Scroll all the way to the left. Hit delete one time. And then we're prompted with this menu. I simply want to get the symbol that I need. 5 is the correct inequality. So now I see I have y greater than or equal to x plus 11. I hit enter. And you can see that the shading that my calculator has done is the same as my shading here. One last detail. Here I said that I indeed said it was solid, but I showed a dashed line for some unknown reason. I'm going to come and make that line dashed. Right. One more time. Since we have the equal to in the inequality, it's a solid line. My line should be solid here. Okay, so in summary, just as before, we needed 2 points. Once we get our 2 points, we decide will the line be dashed or solid. If it has the equal to, it's solid. If it does not have the equal to with the inequality, it's dashed. Lastly, we decide about the shading. 3 ways we can decide the shading. 1 is test a point. 2, use the calculator. Or 3, simply investigate where the y is with relation to the inequality. This says y is greater than, thus the shading is above.